Hello and welcome to another live session at the Reactor. My name is Rebecca and I'll be helping out in the chat today. Before we get into the session, please take a moment to read our code of conduct. We are all here to learn, so please be respectful of other people's views, understanding of differences, and be kind and considerate in the way that you engage. The chat will be open throughout, and we do encourage you all to participate. If you have not been with us before on a live YouTube stream, please ensure you have an account created so you can utilize the chat feature. And then today is the first episode of a 3-part Blazor series. In this first episode, you will learn all about what is Blazor. This session is led by Chris Santi, who is a Microsoft MVP and principal software engineer with over 17 years of experience with ASP.NET. He works at Deployed, a UK-based startup, leading the engineering team. So at this time, I'll pull Chris up onto the screen here. Hello, welcome.
Hi, Rebecca. How are you?
I'm great. Thank you for joining us today, participating in this Reactor session.
My pleasure. Happy to be here.
Awesome. So I will let you take over from here. Thank you all. And again, anybody feel free to interact in the chat. We'll be responding.
Cool. So good evening, everybody. Welcome to this session this evening. I'm going to be talking to you all about Blazor. So this is the first in a 3-part series. This first session, we're going to be dealing with the fundamentals of Blazor. We're going to be laying some groundwork. And this is really a talk that's targeted at people who are brand new to Blazor. So we're going to talk about what Blazor is. We're going to talk about sort of some fundamental architecture principles of Blazor that makes it an interesting technology. And we're going to explore a bit about the hosting models and some projects and look at how a Blazor project is structured and this kind of thing. So before we get into any of the details, let me just quickly reintroduce myself. So like Rebecca said, I'm Chris. I'm a principal software engineer at Deployed. I've been a Microsoft MVP for 3 years now. I have done a lot of blogging at chrissanty.com, but for about the last year and a half, I've been writing a book for Manning called Blazor in Action, which is just about done now and hopefully should be in print soon. So that's been an interesting challenge. But I also do, on top of that, a lot of open source work. So I maintain a group of packages under an organization called Blazor. We've just passed 4 million downloads for the various packages that we have there. So that's a really cool milestone. Hopefully people are finding a lot of value in those. So let's get into it, and let's start with some the real basic one here. So what is Blazor? You might have heard a lot about Blazor. It's certainly a very popular topic in the .NET ecosystem. I think it's fair to say at the moment it's the fastest growing part of the .NET ecosystem, and there's good reason for that. And hopefully by the end of this talk, you should understand a bit about why. So Blazor is a framework for building interactive web-based UIs. The main goal of Blazor, certainly at the onset at least, was to provide a direct competitor to other JavaScript spas like React, Angular, and Vue.js. The key point about Blazor that makes it different to other frameworks is that we can use C# in order to define our logic in the UI instead of JavaScript. And this is not to say that C# is necessarily better than JavaScript and JavaScript is terrible or anything like that. But the way I like to look at this is it's always good to have choice. And for a very long time, there hasn't been any choice in front-end development. It's been JavaScript or nothing. And the technology that Blazor uses to enable this is a very interesting one, and we're going to explore that in more detail through this talk. So a few little facts about Blazor. It's the original creator of Blazor is a guy called Steve Sarnason. So Steve is a principal software developer at Microsoft. He's on the ASP.NET Core team. Steve's got a bit of a pedigree when it comes to front-end frameworks. He's also responsible for Knockout.js. So he definitely knows what he's doing. In terms of the syntax that we use in Blazor, we use Razor to do that. And that's kind of a bit of where the name comes from. The story goes that Blazor is the amalgamation of Razor and browser. I'm not quite sure how that works, but that's the story. If you're unfamiliar with Razor, well, Razor is a technology in .NET that combines C#, HTML, and CSS in order to create web interfaces. Like other front-end frameworks, Blazor uses components in order to compose UIs. This is quite a common thing in front-end frameworks now, and it's probably safe to say that it feels like it's probably the way to build front-end applications. Usually in technology, when everyone starts doing the same thing, that usually means that there's a bit of a winning formula there, and components definitely seem to be the way to go with UIs. Again, like other front-end frameworks, Blazor has a concept of a virtual DOM. Now, virtual DOMs are quite important in SPA-like applications because applying lots and lots of updates to a physical DOM is an expensive operation. So the way we get around this is to perform those operations against a virtual DOM in memory. This can be very fast, and it's used to calculate the minimum number of updates required to change the application's current state to the state that it needs to be, and update the various parts of UI that are going to change, maybe create the look of navigating between pages and this kind of thing. Blazor's version is called a render tree. What it's called is kind of irrelevant, but the concept is the important thing. And finally, it does work in all modern browsers. This is a very important fact indeed. It wouldn't be very good if this was only working on a subset of browsers, but it's not. It's supported by everything, and that includes mobile browsers as well. You can run Blazor applications on Android devices. You can run them on iOS devices, Mac, Windows, Chrome, Firefox, Safari. It doesn't matter. It will run across all those technology or all those different browsers. In terms of the features that are available within Blazor, there's all the kind of stuff you would expect there to be in modern front-end frameworks. So one of the key features, I think, is code sharing for Blazor. Now, this is really for people who are using .NET on the back end. .NET has kind of historically been a server-based technology. We've always needed a .NET runtime on the server, and everything is done server-side. So if you've ever used frameworks like MVC or Razor Pages, in fact, that's all server-calculated stuff. When we've had to do client-side stuff, we've had to resort to using JavaScript frameworks. Let's say like Angular, for example, is a popular combination with .NET. And then you have to go through this motion of creating DTOs that can share data between that API and that client application. Now, that might be done by creating, say, a TypeScript representation of a class in C#. That could be done by code generation, for example. But the point is, it's an extra hop to go through. It's an extra step, and it's very easy for these things to fall out of alignment, especially if you're manually maintaining this client-side and server-side versions of DTOs. Blazor removes that problem because it's all .NET, it's all C#. You can just put your shared models, your DTOs, into a .NET class library and just reference that from Blazor and from your API project. And now you've just got one model that both projects are looking at. Okay, and that makes maintainability much easier. With .NET 6 or .NET 5, in fact, we had some hot reload, initial hot reload stuff came in. .NET 6 is built on that. This is quite fundamental, really, when you're building front-end applications. The developer loop for front-end applications tends to be very rapid. You're making small changes like adding in some markup or maybe tweaking some CSS, and you want that instant feedback. It's very jarring to have to wait for an entire compile cycle like you would do maybe for server-side technologies. So hot reload has been a real welcome addition to the Blazor ecosystem. Another important addition to Blazor has been a technology, an AOT option. Now, AOT stands for ahead of time compilation. Now, this is only really relevant to a particular hosting model that Blazor has. And we're going to talk about hosting models in detail in a little bit. But this particular one is called Blazor WebAssembly. And with AOT mode, we can actually pre-compile a Blazor app to this technology called WebAssembly. Now, we'll talk a little bit, like I say, about WebAssembly in detail later on. So don't worry too much about that for now, but we'll kind of hark back to this in a little bit. We have pre-rendering. This is important for SEO sensitive applications. We can do pre-rendering with Blazor Server, which is another hosting model that does that out of the box. Blazor WebAssembly, it's also possible to do pre-rendering with that using a particular template, which we'll talk about again later. But we can also do things as well, like manipulate the head tag of the host page. So we can do things like change page titles. We can set metadata and all this kind of stuff, which is all really useful if you care about SEO. We have dependency injection baked into Blazor. This is the same DI container that you get in the rest of .NET. So if you're used to dependency injection for, say, like building web APIs or anything like that, then this is all going to look very, very familiar in Blazor. It's all the same stuff. We can create component libraries for Blazor. This is important for sharing our components. One of the sort of real big benefits of component-based UIs is that you can encapsulate pieces of UI and functionality. And then you can, using these component libraries, you can then share these between your applications. Now, that might be creating reusable widgets or particular pieces of sort of UI for your own company style or whatever, or particular controls. And component libraries make sharing those around really, really easy. We've also got access to pretty much all of the .NET ecosystem with Blazor. So that means anything that's on NuGet potentially can be used with Blazor. Now, there are a few caveats to that. When we're running Blazor WebAssembly, we're running in the same security sandbox as JavaScript applications running. In this model, if you're trying to install a NuGet package that wants to, say, do something like play around with the file system, change the registry, this kind of stuff, unfortunately, you are going to see something like a platform not supported exception in that case. That's not really something that's a good idea for browsers to be able to do. But other than that, you will find that a lot of NuGet packages will just work with Blazor, and this can really speed up development of your Blazor applications. We've got a really good debugging experience with Blazor. Now, I will probably caveat this and say it's not quite on par with the rest of .NET. I think the debugging and the general tools that we have in the .NET world are probably some of the best in the industry. We're getting there with debugging with Blazor. I would say that Blazor Server specifically is a very good debugging experience. Almost probably is on par with the rest of .NET. Blazor WebAssembly is getting there. It's very close. There's been huge strides forward in that from the early days when there was no debugging. It was just classic console write lines. But yeah, the technology that's gone into this is pretty amazing. We have JavaScript Interop APIs. Now, these are actually really important. I know one of the selling points for Blazor can be that you don't have to write JavaScript anymore, and that's a fair selling point. And you can definitely write entire applications in Blazor without any JavaScript at all. But there are times where you might want to use it, okay? There can be, say, for example, you want to do a chart. You want to render a chart in your Blazor application. There's some amazing chart libraries in JavaScript. And kind of recreating them in .NET is a lot of work, and it's probably not going to be as efficient as just taking advantage of something that's already there that's well battle tested. And JavaScript Interop APIs for Blazor are very easy to use and make that experience really, really key. In the next session next week, I'm actually going to show you some live coding, and we'll actually explore those JavaScript interops and actually do that exact scenario I've mentioned and see how we can actually wrap a JavaScript chart library inside of a Blazor component and make that a really pleasant experience. The final thing I'm going to highlight here is something called assembly shaking. Now, this is also called IL linking. If you've done any work in JavaScript before, you might also be familiar with the term tree shaking. Essentially, what this means is that when your application is published, we will the compiler will basically try and strip out every code path that's not used, and this is done to reduce the size of your application. Again, this one's kind of only really relevant for Blazor WebAssembly. It doesn't apply so much to another hosting model, Blazor Server. But this is a really interesting technology, and it's really leaning down Blazor applications. In the early days, a sort of initial Blazor application, like a file new project, could be in the region of sort of 1.5 meg, something like that, and it's now under a meg. I think last time I checked, I think it's around 960k or something in that region. Yeah, the size is really coming down, and that's all down to this assembly shaking technology. So that's a little bit of a high level overview about Blazor. So let's start delving into things a little bit more and pull the covers back a little bit. So how does Blazor actually work? Well, architecturally, it's important to understand that Blazor separates how changes are calculated from how they're applied. Now, what do I mean by that? Well, essentially, what happens is the way you write your components, the way you compose them, and you build your applications, that's kind of the app and the component model that Blazor has. And to some degree, that's kind of ignorant of where that application is going to be rendered. Now, rendering is delegated to renderers, as they're called in the code base, but they're more commonly known as hosting models. Now, I've already referred to two of them already so far. So I've talked about Blazor WebAssembly and Blazor Server. They're two hosting models that Blazor has. So let's delve into this a little bit. So the way this works, like I say, is you would build your components in a certain way using a certain syntax. Those will then get executed by Blazor's compiler, and they will be passed to a renderer. Now, Blazor by default ships with a web renderer. This means it's a renderer that knows how to output HTML from the component model. So in this scenario, your components are executed through this web renderer, and HTML is output into the browser. Now, this separation is pretty interesting because we can do funky stuff, and we can kind of move the rendering process around a bit. We can have it running potentially somewhere else other than with the rest of the application. And then you just need some kind of transport technology to connect the two. And at this point, we can then just again ship our updates to this renderer, and that can be responsible for rendering the client at the HTML. But where this is really interesting is where we actually scrap the web renderer entirely and replace it with a different renderer. Now, this might be something that knows how to render a particular native UI format, say iOS or Android or whatever. And this is an interesting one where that same kind of component model can be used. And this time, when it runs through the native renderer, it can output, say, a native mobile UI. So this is interesting stuff. Now, like I said, there's two primary hosting models at the moment with Blazor, and there's kind of a third that's just emerged with kind of .NET 6, which I'll talk about in a little bit. So the two primary ones are Server and WebAssembly. Now, Server is actually I'll try that again, untangle my tongue, is the oldest hosting model that Blazor has. This was the original hosting model that was released when Blazor first became GA. WebAssembly followed a few months later. Now, in this model, weirdly enough, your application does actually run on the server. Now, you might be like, well, Chris, that's a little weird because isn't this meant to be a SPA application? Well, it is and it isn't. It's an interesting one. With Blazor Server, it will feel like a SPA. It acts like a SPA. But everything is being executed on the server, and there's a Signal R connection that is set up between the server and the client. And there's a small JavaScript runtime that basically bootstraps that Signal R connection. And what happens is all of the interactions the user has with that application are shipped over that Signal R connection back to the server. All the UI diffs are calculated on the server for that particular client, and then any UI updates are shipped back over that Signal R connection, where they then get applied in the client's browser. Now, this might sound like it's going to be a terrible technology. It's going to be really slow, but actually it's really, really fast. I'm going to show you this in action in a little bit. And the second hosting model to come along was Blazor WebAssembly. Now, this is the one that carried most of the hype, and specifically because of this technology that it leveraged called WebAssembly. Now, Blazor WebAssembly is your true SPA competitor. Everything runs in the client browser. Everything, your entire application downloads there. You could then at that point theoretically take away the server element, and the application would continue to function similar to how an Angular app would, or a React app, or a Vue.js app would. Now, one thing that is important to understand, like I said, this separation between hosting models and component model, is that components are composed the same way for either of these hosting models. Now, to show you what a component looks like, this is an example component. So components in Blazor by default kind of have two halves to them. The first half, the top half there, is like your markup section. And you can see, if you're familiar with HTML and everything, this all looks pretty standard stuff, but there's a couple of bits that might look a little funky. So first of all, we've got this at current count, and this is a piece of Razor syntax. So this is going to output the value of a field, which is declared down in the bottom in the code block. We also have an on-click handler on the button, and this is a Blazor on-click handler rather than a JavaScript one. And again, it's got that little at symbol at the front of it. And here we're saying when we click the button, call this method increment count that's going to handle this event. And we can see that, again, defined in our code block. So the second half of our component is this code block. And this is just a place we can put any C# we wish. Okay, so any valid C# is okay here. So you can see in this example, we have a field and we have a method, but we could even define classes, enums, whatever in here. Any valid C# can go in the code block. Now, another important thing to understand about components, Blazor components, and just as well, I'll touch on this just so everyone's aware, because I saw this come up on Twitter recently, is that their official name is actually Razor components. So they're called Razor components because of the syntax they use. They use Razor syntax, but that you're more commonly seeing them referred to as Blazor components. But one key thing to understand about them in comparison to other Razor technologies, so if you've used say MVC, or you've used Razor pages, Blazor components work differently. In those server-side technologies, MVC and Razor pages, when those apps are run and that code is executed, they output an HTML string. Blazor components don't do that. Blazor components are actually compiled into a class. Okay, so this is kind of a trimmed out, simplified version of what a Blazor component gets compiled to. So Blazor's compiler basically takes that component that we saw on the last slide, and it creates this component, and it creates this method build render tree. And inside of here, you can see that each of those pieces of markup has now been translated into an instruction. And you might notice as well that these are pretty non-specific instructions. There's nothing here that necessarily says that this is anything to do with HTML. So we have open element, we have add content, close element, markup content, attributes. Obviously, while these are things that you could definitely map to HTML, you could also easily map these to XAML, for example, that has the same concepts. And this is that, like I mentioned, that kind of separation that you're seeing. So this gets executed, and the renderer, the specific renderer, is going to interpret those instructions into the correct UI elements, so HTML divs or p tags or whatever. So Blazor WebAssembly, let's go into the details on this one. Now, before we can really start talking about Blazor WebAssembly, I think it's important that we cover the topic of WebAssembly itself first, so we can all have an understanding of what that is. So WebAssembly is abbreviated. You might also hear it termed as WASM. Okay, and WebAssembly is a binary code format, and the real big selling point for WebAssembly is that it's very fast. Okay, the promise of WebAssembly is near native speeds in the browser. Now, this is a really interesting one, mainly as well because of what WebAssembly is going to be used for, which we'll get into now, which is as a compilation target for higher level languages. Now, while you can technically write WebAssembly directly yourself, there's like a textual version of it. Like I said, it is a binary format. by design. And it's like I say, it's been designed to be targeted by high level languages. So C++, Rust, Go, and C#, for example, they're all things that can be compiled down to WebAssembly. Now, for reference, this is kind of what it looks like in its textual format. So we've got a C++ function on the left-hand side here. And on the right-hand side, we've got what it would look like in WASM. Okay, so you can kind of see how it would look from a textual perspective. It's not really something that I would personally like to be coding in, but you could technically do it if you wanted to. A really key thing to understand about WebAssembly is that it is a web standard. That means it's not going to go anywhere. In fact, it's actually the fourth language of the web. Now, this is something that was ratified, I think, 5th of December 2019, I think, something like that, by the W3C. So just to be clear, in the whole history of the internet, we only have 4 official languages. We have HTML, CSS, JavaScript, and now WebAssembly. So it's a big deal that this is now a web standard. They don't come around very often. So yeah, this is not going anywhere. It's here to stay. And it's supported by all major browsers. This has been in all major browsers for quite a while now in its initial format. And WebAssembly is a developing standard. There is more coming, and it's going to have more potential longer term. So how does this actually fit with Blazor WebAssembly then? Well, interestingly, by default, at least with .NET 6 now, your application is not compiled to WebAssembly. It's a common misconception that people think that Blazor WebAssembly applications are all compiled to WebAssembly. That's not true. What happens is the .NET runtime, mono.NET, is compiled through a toolchain called Inscripton. And outside, you sort of pass in the .NET runtime on one side, and out the other side comes this file called .NET.wasm. And that is that .NET runtime compiled to WebAssembly. This is the only part of your application, or this is the only part that is actually WebAssembly. Like I said, your application is not compiled to WebAssembly by default. Now, earlier in the talk, I mentioned about AOT, and this is where AOT comes in. So with .NET 6 and AOT being made available for Blazor WebAssembly apps, you can now compile all of your code to WebAssembly. Now, there's 2 things to understand about that. Firstly, you're going to get a really big performance boost, about 5 times performance. It's a really big thing. So this is specific to CPU intensive actions. So if you're doing CPU intensive stuff, say some kind of image manipulation, for example, compiling your whole app to WebAssembly is going to have a serious impact on performance. It's going to really improve things a lot. However, there's no free lunches. And unfortunately, compiling your app to WebAssembly is going to get you those performance increases. It's also going to double the size of the app. .NET IL is actually pretty compact. And as compact as WebAssembly is, it's not quite as compact as that. So you are going to pay a 2 times increase in terms of size. Something that's probably worth mentioning at this point as well is that coming in .NET 7 is potentially going to be partial compilation to WebAssembly. Now, if this goes through and the team managed to deliver on it, it will mean that essentially you'll be able to compile specific parts of your application to WebAssembly. And I think for me personally, this is the sweet spot with AOT. Most apps don't need every part of them to have that kind of high performance mode. They just need specific parts. And that way you kind of get the best of both worlds, really. You get to keep your app size as small as possible, but you do get the performance in the areas where you need it. And I think that's going to be a popular option going forward. So how does a Blazor WebAssembly application actually work? How does it actually work in a browser? How does it run? Well, let's look. So let's pretend we're going to go to this Blazor WebAssembly app at wasm.blazor.net. This isn't a real URL, by the way. Well, we're going to start off by making our request to the server as you would with any other web app. Now, at this point, the web server is going to return back static assets. And this is a key thing to understand, that Blazor WebAssembly apps are compiled to static files. That means you do not need a .NET runtime on the server. Now, this is something that we've never had before with .NET. We've always needed a runtime on the server. But this means that Blazor WebAssembly apps can be hosted on free hosting. So GitHub pages Netlify, things like Amazon S3 buckets, Azure, blob storage, stuff like that. You can host Blazor WebAssembly apps and all of that stuff, which is a really cool thing. Now, in terms of what we get back here, we're going to get a static HTML page. This is going to be the host page of our app, our single page for our single page app. Any CSS, images, JavaScript files, .NET, that .NET.wasm file, which is our runtime compiled to WebAssembly. And finally, we're going to get application DLLs. Like I said, by default, our app is not compiled to WebAssembly. You just get .NET DLLs downloaded to the browser. Now, once we get into the browser is going to do its thing. It's going to construct the DOM, and it's going to execute a file called Blazor WebAssembly.js. So this is a kind of piece of Blazor that lives in the JavaScript world. Now, the reason for that, I'll go into in a bit more in a second, but we'll just leave it there for now. The primary job it's got at this point, this particular file, is to bootstrap that .NET.wasm runtime. Okay, so it's going to bootstrap that and get it running. It's going to then load the Blazor framework, and then your app is going to get loaded on top of that. Now, at this point, we have a fully running app in the browser. We now don't need the web server anymore, unless the app needs to call out to get additional data. But say we've got a game, for example, this would now just run in the browser. We could go offline. It's not a problem. So that's our Blazor WebAssembly app boot up process. Slightly simplified, admittedly. So what about UI updates? How does that work? Okay, so let's pretend we've got this page that's showing some search results, and we want to click this load more button and load in the next chunk of search results. How does Blazor process and apply these updates? Well, we're going to click on that button, and that's that click event's going to get intercepted by that Blazor runtime that sits in JavaScript. Now, it's going to intercept that event, and it's going to pass it up through into your C# code and to your component that's going to handle that event. So we're going to have a search component here that's going to handle that particular click event. Now, in that handler, we're going to say make an API call to go get our next chunk of data. So that would be done using the regular HTTP client from .NET. When it's in Blazor, though, it's configured slightly differently under the hood. It's actually configured to use a bit of JS Interop, and it calls into the browser's fetch API. So we actually go down to that bit of Blazor in JavaScript again, and then we make the call out to the API. But this is totally opaque to you as a developer, okay? I'm showing you what's going on under the hood, but you kind of, in a way, don't really need to care too much about this. When the data comes back, it gets sent back to your component, and you might update some state in that component for it. So say we've got a list with the search results that we're iterating over to print out on the screen. We might update that list with these new search results that have come back. That would effectively change the state in that component. This would trigger Blazor to perform a new UI update, okay? And it would calculate what changes it needs to apply in order to update the current page with this new data. And it bundles them up in something called a render batch. So render batch is just a technical term for basically a group of UI updates. So these then get shipped back into that bit of Blazor in JavaScript. Now, this is where I'll talk a bit about this. So the reason we're doing all this back and forth with JavaScript is that WebAssembly actually has a bit of a limitation at the moment. It can't actually manipulate the DOM in a browser, and it can't make any calls into browser APIs. It effectively is only really good at manipulating memory, essentially, just really fast. So this is why we have this bit of Blazor that sits there. There are improvements to the WebAssembly spec that would deal with this and actually have native APIs in WebAssembly to be able to do this. And when they come along, we won't need all this bit of Blazor to be sitting in JavaScript. But for now, that's why it's there. So this bit of Blazor is going to apply those updates to the DOM. And at that point, it's going to do a re-render, and we're going to see that change in the browser. And at that point, that's the end of our UI update. So let's jump out of PowerPoint and actually go and have a look what a Blazor WebAssembly application would look like. So let's jump out of there. I'm going to bring across Visual Studio. Now, before I go any further, I'm just going to take a quick look and see what questions we've got going on. So let's have a look here. Is it possible to switch between Blazor WebAssembly and server configurations? That's from Fred Hendricks. Yes, it's technically possible. You can do that. There was a few examples kicking around, certainly in the earlier days of Blazor for doing that. I think it would depend what your app's doing as to whether you would necessarily want to go through that process. It's not overly straightforward. It's certainly not documented, but it is technically possible. So I won't say any more on that because, like I say, there's so many nuances about that. I'm not sure I could add a huge amount more without knowing more about the specific scenario. So next question, does Blazor desktop exist? Does Blazor mobile exist, or is it Blazor mobile bindings? Cool. What I'm going to do is I'll pause on that one because we're going to come back to that one a little bit later in the talk. So we'll cover that one then. And I think that puts us about up to date with things. So excellent stuff. So we'll jump into Visual Studio now and have a look at a Blazor WebAssembly project. Okay, so I'm going to create a new project here. I'm going to go down and I'm going to find my template here, which is a Blazor WebAssembly app. Click next. Blazor app 44, where you can tell I create a lot of these. So we'll hit next. .NET 6 here, and I'll hit create. Cool. So this is our Blazor WebAssembly application. Okay. So before we go any further, what I'm going to do is I'm just going to actually run this so we can have a quick look at what this looks like and what the experience feels like. So let me drag in my browser here. So if you've seen any stuff about Blazor before, you probably have seen this template plenty of times. It's a pretty simple template, but it demonstrates a few bits about functionality. One of the key ones is the counter, basically because we're seeing dynamic UI updates here. So I can click this counter and we can see the count increment in real time. There's no postbacks going on here. This is all happening in my client browser. If I go to this fetch data page, you can see that it's rendering out some data based on some data it's calling using the HTTP client. So fairly straightforward. But what we'll do while we're here is have a look in DevTools and have a little look here at what's going on. So the first thing I'm going to do is I'm going to go to the application tab and I'm going to go to the cache. And if we go in here, we can find a lot of files. Okay. Now, if you have a look here, these are all regular .NET DLLs. Okay. So you can see the .dll extension. They have this unique code appended to them as part of the build process for busting caches. So don't worry about all of that. But these are just regular DLLs. So first of all, here you can see our actual application DLL. So Blazor app 44.dll, that's at the top there. We can see framework DLLs. So we've got the ASP.NET Core framework DLLs going on there. And if we go down, we can then see basecast library stuff and all of the system stuff. As you can see, there's quite a lot going on here and everything. And right down at the bottom, we can see this .NET.wasm file. And this is our .NET runtime compiled to WebAssembly that we were looking at earlier. Okay, so I just want it to be really clear about this. That is really running .NET DLLs in the browser, executing them using a just-in-time interpreter. It's not just-in-time compilation like JITting in the rest of .NET. This is using an interpreter, hence it's not always the most performant for CPU-bound stuff, which is where AOT comes in. But these are real DLLs. You could take these and run them on any .NET runtime and they would just execute. There's nothing special about them in that regard. Cool. So let's jump back and look at the actual files in this project. So like other .NET ASP.NET Core applications, the entry point is a program CS file. Okay, so this is using the new top-level statement stuff that's in all the templates now with .NET 6. So inside here, we have a WebAssembly host builder, and then we add in some root components. So like I said, we use components to compose UIs, and there has to be a top-level entry component for our app, and this is one called app here. This head outlet one is another root component, but it's there for doing manipulation of page titles and stuff. It's not kind of part of the main app structure. So that one's slightly different. We've got, like I said earlier, we've got the same DI container we have in the rest of .NET. So you can see we've got this builder.services. I can add a scope service. In this case, it's adding the HTTP client here, but I could register any other services I wanted to at this point. And then again, like other ASP.NET Core apps, I can just call build and run async to run this application. So if let's go down to this app component. So this is our entry point to our Blazor app. We'll go in here and we can see the first thing we can see here is this new green syntax. Okay, and this denotes a component. So this particular one is the router component. So this is responsible for all of the client-side routing in our Blazor app. What happens with the router is when the application boots up, it goes off and it scans the assembly that we pass it here, which is by default that project. And it tries to find any page components. Okay. And I'll talk about page components in a second. Once it does that, it kind of builds up a table so it knows what those page components are and what routes they're responsible for. And then whenever you try to navigate within the client app, it goes to that table, finds the route that matches the one you've asked for, and then loads the component that's responsible for that route. And it does so using this found template. So that's where your page component would be loaded. We can do things like define layouts. Okay, so if you've done MVC and Razor pages, this concept will be familiar to you. We can basically have common UI like headers and footers and maybe nav menus defined in a layout, and then just load pages into a specific place within that layout. And we'll look at that next as well. So that's in our shared folder. We have that main layout. So we inherit from a type called layout component base to define a layout. And that gives us access to this body tag. And this is, or this body property, sorry. And this is going to be where the page loads. Okay. So if I go to the counter page, the markup from the counter page will be loaded right here. Back to our router. If anything goes wrong, we can't find it. If we request a page that doesn't exist, then the not found template is used. It sets the page title here. You can see using the page title component. And then it's just going to render out this p tag saying that there's nothing at this address. Okay. So there's a quick whiz around the router. Again, if you don't understand everything in detail there, don't worry about it. We'll kind of go through this more as we go through things. Next, we'll talk about these pages. Okay, so there's this pages folder. Now, these denote page components, or technically their official name is called routable components. Now, I don't like using that name as much because I think page component makes it easier to understand for people. Firstly, because in the template, it's in a folder called pages. Secondly, what makes these components page components is that they have this page directive at the top of them. So again, everything kind of to me makes sense to just call them page components. Page components, basically, like I said, the only difference between these and regular components is they have the page directive declared at the top. And then this has got two parts to it. So we have the declaration of the directive, and then in quotes, we have the route that this particular component is going to be loaded for. So what route it's responsible for. So when we have a // like this, that means that it's the root page for our app. But if we go to, say, the counter page, for example, that's going to load when we go to /counter within our app. So this is hopefully sort of quite straightforward how this works. And this is what the router component looks for when it scans that assembly. It looks for any components with this page directive, and that's how it understands the difference between a page component and a regular component. While we're on this counter component, we saw this in action a second ago in the running app. We could click that button and increment the count, and this is it in action. So this will look familiar from the earlier slide in the talk. We've got the current count field here. We've got the increment count method that just adds 1 to the current count each time. And then we've got this bit of Razor markup here that outputs the value of the current count field. Okay. So it's quite intuitive, I think, Razor. It sort of reads really well. I can sort of just at and then print out the field I want. On click, increment count, it kind of flows for me. I quite like that. I mean, obviously, it comes down to how well you name things, admittedly, but I think the syntax is relatively straightforward. Finally, we'll just have a quick look at this fetch data page. So here we're doing some dependency injection. So we can inject services into Blazor components using the inject directive. We specify the type that we want injected, and then whatever the name that we're going to have for it locally. So in this case, it's going to be referred via this HTTP moniker. If we look down in the code here, and we come down to the bottom, we can see a bit of what I was saying about earlier with this code block. So in here, we've got a class defined, which is this weather forecast type. And then we also have this special method here called onInitializedAsync. So this is actually a lifecycle method in Blazor. So Blazor components have three lifecycle methods. They have onInitialized, they have onParametersSet, and they have onAfterRender. And all of those have an async and a synchronous equivalent. So in onInitialized, it only runs once in the component's lifecycle. So you can think of this a bit like a constructor in a class. It makes it really useful for doing things like loading some initial data. And that's exactly what's happening here. So we're using the HTTP client. We're using this JSON extension, which is get from JSON async. We can pass in the type that we want the return value deserialized to. So in this case, an array of weather forecasts. And then we can just type in the URL for the endpoint we want to hit. Now, in this case, it's just hitting a local JSON file, but it could easily be hitting an API. When that comes back, those forecasts are going to be stored in this forecasts field that's defined here. If we scroll up a bit, we can see a little bit more in-depth use of C# and Razor here. So we have an if statement. Again, we start off with that @ symbol, and we're saying if the forecast is null, then show this loading message. Once forecast is not null, then show this table. And then down here, we're going to for each through each forecast and print out a row for each of the forecasts in that array. Now, this is an example of where Blazor will do its change detection and stuff. So when onInitialized executes, at the end of this method running, Blazor is going to perform a UI update. And so it's going to reevaluate essentially that if statement at the top here and check if forecast is still null. If we've got some data back, which we do because it's hard-coded here or practically hard-coded, this is now no longer null, and that's what's going to trigger the update to show the table. So that's a bit about the components and sort of a high-level structure. The other thing to point out in here is in this www root folder, this is where we can put static assets, okay? So inside of here, we've got an index.html file. And this is the host page for our application. So inside of here, we have a div with an ID of app. Now, this is where our main app, our top level app component is going to get loaded, okay? And that was defined. We link all this together in the program file. So you can see here, we're saying that the root component is app, and it's going to be loaded into an element with an ID of app. So this is a CSS selector right here, okay? If we go back to the index page, so that matches here. So the contents of this div is going to get replaced with our application here. So this loading will be replaced with our app. We can see the reference to that Blazor WebAssembly JS file down at the bottom. And that's kind of all the important stuff that's really going on here. There's some other bits in here, but at this point, we don't really need to care. But we can just see how these bits that we've talked about all hang together now. Cool. Now, this particular project I'm showing you is what's called Blazor WebAssembly Standalone. So this is just a single project with Blazor WebAssembly. We'd need to, if we wanted some server-based stuff, like we want to save stuff to a database, we would need to have an API that would then save and talk to a database and things like that. So there is actually another template for Blazor WebAssembly called Blazor WebAssembly Hosted. And that's a template that actually provides you with that API. So just to show you what that looks like in comparison, if I just go new project, we'll go Blazor WebAssembly again. Now on this second screen, I'm going to tick this box called ASP.NET Core Hosted and hit create. And it's going to basically give us exactly the same client-side app that we had before, which is this Blazor app45.client, which is what we just looked at. But we also get a ASP.NET Core Web API, and we also get a .NET shared class library for shared classes. So we have a controller here for weather forecasts. It's going to return weather forecast data. We have the weather forecast DTO now defined inside of that shared project and referenced by the server and referenced by the client. So that's that code sharing I was talking about earlier. Cool. So I'm going to move on from this now because that hopefully covers the kind of main points here. So in terms of summarizing this, what are the benefits of this? Well, first, it runs on the client, Blazor WebAssembly, which means we can offload the work to the client, which is great for scalability. We can also work offline really easily. The eagle-eyed among you may have noticed when I was creating those projects, there's actually a tick box for creating a PWA. Blazor WebAssembly can be made into a PWA very, very simply. If we're using that standalone template, we can actually deploy it as static files. If we're using the hosted version, that's not the same. We do have an API there, so we do need a .NET runtime in that instance. But if you do a standalone project, you can use static files, and free and cheap hosting is then available to you. And like I said, we have code sharing. Okay, that is something that I cannot, sort of say the value of enough. If you're using .NET on the back end, sharing that code is really, really a really big selling point. Now, in terms of the trade-offs, performance is one of them if you're doing CPU-intensive tasks. Like I said, if you're not doing CPU-intensive tasks, then it's not really a problem for you. Payload size, that might be a problem for you. It really depends on your audience and stuff. But once that application that we were just looking at, once that's been published and stripped, that's under a meg. But obviously, that's still not as small as some JavaScript apps. At this point, I kind of like to say really that the simple truth is Blazor is never going to be as small as a JavaScript app. It can't really compete. It needs a .NET runtime. JavaScript apps don't. So it's never going to be that small. So if you're ever building apps that are absolutely critical to have the smallest app possible, then Blazor is probably not going to be the right choice for you, unfortunately. Load time, that's basically a direct effect of the payload size and what kind of connection your users have. But if they have slow connections and that payload size is an issue, then load time is going to be apparent because all that's got to download before the app can be booted. And the last bit is you're running on a restricted runtime. So this is restricted in terms of what you get on a server because you can still do everything that JavaScript can. You're just limited by that browser sandbox, that security sandbox. So let's do a quick comparison with Blazor Server. So Blazor Server will do the same principle. So what does this look like? Well, when we boot up a Blazor Server app, we do the same as we do with WebAssembly. We make the initial call, except the difference here is the app may actually already be running. Okay, that's because we're going to connect to the server, and the server is where all the application, like I say, where the application is actually running. So if other people are already using the site, then the app's going to be spun up and we're just going to connect to it as a new client. What we do is we get back some compiled HTML this time. So Blazor Server doesn't use an index.html like Blazor WebAssembly does. It actually uses a Razor page as its host page. So we do get compiled HTML this time in comparison. And we do get the usual stuff, CSS, images, JS files, but no WebAssembly, no nothing, because we don't need that because we're running on the server this time. Same as before, the DOM gets constructed, and then this time we have a blazor.server.js file. And this has got a small runtime in it, and its main job at this point is to set up a SignalR hub and establish a SignalR connection with that Blazor application running on the server. At this point, we now have a running application. That's it. That's all there is. So Blazor Server apps actually load really, really quickly. Okay, almost instantly, in fact, sometimes. So in comparison to WebAssembly, there's just not all that download that has to happen. There's no .NET runtime that's got to be downloaded. Same as before, how does this compare like with Blazor WebAssembly when it comes to UI updates? Well, things are a little bit more complex here. So same principle as before, we're going to click our Load More button. That's going to get caught by that bit of Blazor that's running on the client and sent back over the SignalR connection to the main application running on the server. That's then going to get processed, and your application code is going to be called, and your event handler inside of the search component is going to be run. Now, because we're on the server, we might not need to make an API call here. We might just go and call a service to go to a database and just get the information straight out of that. That can then be applied to the list that's on that search component, same as before. And that would, again, trigger Blazor to do a UI update because we've changed that state of that component. Blazor will work out the smallest number of updates it needs to do. And again, it will create a render batch. And this time, the render batch will be shipped over that SignalR connection to that Blazor runtime on the client, which is where it will get applied to the DOM. And that's where you'll see the update. Okay. So this may seem really convoluted to some of you. So let's actually go and have a quick look at this in action. Okay. So if we look at the equivalent project now and we do a new Blazor server app. So we'll run this. Now, I'm just going to go straight to running this because, frankly, all of pretty much the code and how things work is identical between the two. The thing that I really want to show off here is the fact that the user experience is effectively identical. Okay, I can go between these pages. It's sharp. It's snappy. These clicks happen instantaneously. The user experience really isn't degraded. In fact, I go as far as saying that if I gave you these apps side by side, if you didn't look in the browser DevTools, you wouldn't know the difference. The experience is practically indistinguishable. And this is the interesting part because we're getting this spa-like feel and all the benefits of a spa, but also having everything happen on the server and getting that the benefit of running on a full .NET runtime on the server side. Like I said, the actual project structure is pretty much the same as a WebAssembly app. The difference here is that there is this host.cshtml page, which is a Razor page, and it contains this component tag helper. And this is basically where your app will be rendered into instead of that div that we had in Blazor WebAssembly. We specify the type of the entry point component for the app, which is, like I say, by tradition, it's called app.razor and sits in the root. But other than that, these files are identical. So we have the same counter page we had before. We have the same fetch data page we had before. We have the same index page we had before. Okay, so nothing's really different here in terms of the components. It's just where it's hosted. So at this point, I'd like to address this question because it's usually the burning one on people who are new to this, which is, can it scale and what's the performance like? Well, the .NET team actually did some experiments here. So they did these back in, I think, 2019 again, which was to see how many concurrent users Blazor server apps could support. Well, on a standard D1 v2 instance in Azure, which is a virtual CPU and 3.5 gig of memory, it could deal with 5,000 concurrent users. So that's active users clicking around. That's not just sitting there idly connected. So that's quite a lot. And they found that if they scaled that with 4 CPU cores and 14 gig of memory, which is D3 v2 instance, it could do over 20,000 concurrent connections. So that's quite a big deal. Okay, that's pretty impressive performance. The caveat of this was latency. What they found was latency affected things because you do have to do round trips to the server for everything. It does mean that if your client is more than about 200 milliseconds away from your server, they're going to feel a little bit of a lag in that UI. So that's something that you have to consider with Blazor Server. Now, in terms of benefits, it's a small payload. There's no .NET runtime to download, which means that the Blazor Server apps have a very fast load time. And also with Blazor Server, things are also pre-rendered by default. Okay, so if you want SEO, you get it kind of out of the box with Blazor Server. You get access to the full .NET runtime with Blazor Server because it's running on the server. Okay, it's not running on the client. And you also get code security. Okay, so some people are a bit nervous about having their application DLLs downloaded to a client browser and executed. What I would say to that is never put anything in those DLLs that you would consider proprietary. Keep that behind your API. But if you're really worried about it, you can just use Blazor Server and everything will stay on the server and just those UI diffs get sent down to the client. In terms of trade-offs, well, it does create a heavy load on the server. We've now got kind of a client-terminal relationship going on. So your server needs to be beefy enough to deal with all the clients that you have. It also means that it can't work offline because you do need that server because that's where your application is running. If that connection is broken, so if your users have an intermittent connection, they're not going to get a very good experience with Blazor Server. As I mentioned a second ago as well, latency really matters. Anything above 200 milliseconds, you're going to see some slight lag in the UI. So essentially what this means is that you need a pretty fast and stable internet connection for Blazor Server apps to really be beneficial. So just to wrap up here, let's quickly talk about the future of Blazor. So this harks back to the question that we had a little earlier, which was around Blazor Desktop. So Blazor Desktop is a thing, but it's been branded as Blazor Hybrid, and this is part of .NET MAUI. Okay, so this is something that is currently in preview and is looking to be released, I think, around build time. So sort of end of May-ish, I think, something like that. In this model, we can actually run Blazor components inside of a desktop shell or mobile shell for that matter. So effectively, it's kind of like Electron, but for .NET Blazor apps. Okay. Now, with this hosting model, the nice thing about this model is that it shares. You can share the same components that you would use in your web app. So a component that you wrote that was running on Blazor WebAssembly or Blazor Server can also run on Blazor Hybrid. Okay, so this is the component that we saw earlier. That will execute perfectly fine on Blazor Hybrid, which makes it a real appealing option if you have applications that need to run, say, on web, on mobile, and on desktop. Okay, you can actually write the application once and have it rendered in those different formats using Blazor Hybrid. The other one is an experimental one called Mobile Blazor Bindings. Now, this has been an experiment for quite some time. I think over 2 years or getting on for 2 years. My personal view is that it probably won't be a thing, but I don't know. I've got no inside knowledge or anything here, but I think it maybe would have seen more light of day, I guess, if it was maybe going to move on, but who knows? The reason I don't think it will probably be as brought into things and made official is because of the fact that we do need to use a different type of component here. So you can see here that the structure is the same as the last one, but we now have this stack layout and label and button. And these are native UI elements rather than sort of more the HTML derived version. And this is why I don't think it'll work, because you'd have to rewrite your components. You couldn't use the same components that you used in Blazor WebAssembly and Blazor Server and Blazor Hybrid. You would have to write them specifically for this model. And I think that's really where the sticking point would be. So basically, to sum up here, if you think of .NET as a platform for building anything, and you really can build anything with .NET, desktop apps, web, cloud apps, mobile apps, games, IoT, device applications, and AI, it really is a very vibrant platform that you can do a lot of stuff with. You can essentially think of Blazor as a framework for building any UI for your app. So you can build desktop apps, mobile apps, and web apps using Blazor as your UI framework. And I think that's quite a compelling reason to check out Blazor. So just to finish up a couple of useful resources here for you. So we've got the official Blazor site at blazor.net. We have Awesome Blazor, which is you can get to through the short link aka.ms/awesomeblazor. And that's a community repo that showcases loads and loads of Blazor projects, from NuGet packages to blog posts to videos. It's just got everything on it. It's a fantastic sort of one-stop shop for Blazor stuff. Blazor University is definitely worth checking out as well. It's a free site built by someone in the community called Peter Morris. Peter's a very knowledgeable guy, and he's put a lot of time and effort into Blazor University, and definitely I always recommend people to check that out. And of course, my blog is available as well. I think I've got 70 odd blog posts now on Blazor and stuff. So hopefully there's some useful stuff for you there. As I mentioned, I also have been writing a book, so Blazor in Action. So if you want to get a more in-depth view of Blazor and build out a whole app at more production level, then please feel free to check this out. And there's a discount code there as well if you are interested in doing that. You can get that from manning.com. And yeah, that's kind of it really. So if we've got any questions, I know we're slightly over here, but if we've got a second or two, let's have a quick look. So when would it be ideal to deploy Blazor over a traditional application and vice versa? Good question. So I honestly think at the moment, the answer to that question is based on what is the skill set of your team. If you have a team who are .NET based, they have a .NET skill set, and you need to build a rich UI application, web application, then I think using Blazor makes a lot of sense. You can reuse that skill set. the learning curve for Blazor is really shallow if you're used to building .NET applications. So I think that's really where it's got the biggest appeal. Conversely, as I mentioned, like there's a vice versa thing. What I wouldn't do is go out and rewrite your entire AngularJS app from scratch just because Blazor's come out. Like everything, they're tools. You shouldn't change something that's working just for the sake of it. And again, if you have an experienced front end team that know JavaScript, having to sort of relearn .NET is probably not the most efficient thing from a business perspective. So next, can you offer guidance on mechanisms to incorporate WebGL with Blazor? I'll be honest, I personally don't have any experience with WebGL and Blazor, but I would check out Awesome Blazor and have a look on there because I'm sure I've seen someone play around with it. And if someone did, there would definitely be a link off of it on Awesome Blazor. So I'd suggest checking that out. Can you mention my book yeah, so like I said, it's called Blazor in Action, and its publisher is Manning, so you can find it on manning.com. And I think it is also on Amazon for pre-order, but the discount code that I showed would only work on Manning's website. So yeah. Next one. In order to display 3D charts in a Blazor app, is JS Interop with the JavaScript library named High Charts the best option, or is there a Blazor component that is available? Good question. There probably are, at this point, there probably are Blazor. I've seen Blazor chart libraries available. I think, bar one, I think all of them have been wrapping JavaScript libraries. So the nice thing about obviously the community getting involved in all this stuff is that if someone goes to the trouble of wrapping a JS library, you can just use that as a NuGet package, and you don't really need to care that it's using JavaScript under the hood. Someone else has done all that work for you, and that's why I'll talk about that next week as well. We'll actually do that. So I would suggest checking again. I would check Awesome Blazor. It's definitely the place to look for something like that. There's loads of links to NuGet packages for chart stuff. See if there's the one that does what you want it to do or uses the library you want it to. If not, then yes, JS Interop, I would suggest, is the best way to deal with that. Cool. So I think that's everything. Someone said about the discount code. The discount code is AU35SAI. So if you do want to check that out, that's the code. But other than that, I think that's all the questions. So yeah, thank you everybody for coming. I hope this has been useful, and tune in next week, and we'll go a bit further down the Blazor rabbit hole.
Thank you so much, Chris. This was fantastic. And thank you to our audience for tuning in. This session will be available on demand if you need to reference anything later on. And then again, as Chris mentioned, we'll be having the second part of this series happening next week. So find us on Meetup. You can search for your local Meetup Reactor location through our website link. And then check us out. Come to the next one. See you there. Take care now.